This is SpaceTime, Series 23, Episode 36. Coming up on SpaceTime, the brightest supernova ever seen. Bepi Columbo swoops past the Earth at 30 kilometres per second. And discovery of fine threads of million-degree plasma woven through the Sun's atmosphere. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the brightest, most energetic and likely most massive supernova ever seen. A supernova is the spectacular explosive destruction of a star in a blast so bright and powerful it can briefly outshine an entire galaxy. Stars shine by fusing hydrogen in their cores into helium, and they can happily continue doing this for millions, even billions of years. Stars doing so are said to be on the main sequence. But eventually the core hydrogen starts to run out, and this causes the delicate balancing act between gravity crushing the star down towards its centre and nuclear energy pushing the star outwards to end, and gravity wins, causing the stellar core to collapse inwards. Now, this additional mass crushing down causes a dramatic increase in pressure and temperature in the core, eventually triggering a helium flash, making it hot enough for the core to begin fusing helium into carbon and oxygen. At the same time, a hydrogen shell begins burning around the core, and the star's outer layers expand dramatically due to the increased heat. And because it's now further away from the core, the outer envelope of the star is also cooling down further, in the process turning more red in colour. The star has transformed into a red giant. Eventually, low-mass stars like our Sun fuse most of their core helium into carbon and oxygen. But because they're below what's known as the Chandrasekhar limit, which is around 1.44 times the mass of the Sun, they don't have enough mass to fuse the carbon and oxygen in their core into heavier elements, and so the fusion process ends. This Chandrasekhar limit's important in physics because it's a barrier for something called electron degeneracy, the quantum mechanical effect arising from the Pauli exclusion principle, which prevents more than one fermion, such as an electron, from being in the same minimum energy level quantum state at the same time. In simple terms, it's the most you can squish something down. Now, eventually, what's left behind is the now exposed white-hot core, known as a white dwarf, an object about the size of the Earth, which will slowly cool down over the eons, and eventually, in trillions of years' time, become a black dwarf. However, stars far more massive than the Sun face a very different fate. Because they're so massive, with higher core temperatures and pressures, they fuse hydrogen to helium through a different process, and then go on to fuse progressively heavier and heavier elements: carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. But iron is the end of the line. No matter how massive a star is, it's not massive enough to fuse iron into heavier elements. And so the delicate balancing act between gravity crushing the star down towards the centre and the nuclear energy pushing outwards reaches its final conclusion. And once again, gravity's the winner, causing the star to collapse. But these stars have enough mass that their immense gravitational collapse is able to push through the electron degeneracy barrier of the Chandrasekhar limit, crushing the core's negatively charged electrons and positively charged protons together to form neutrons, tightly packed into a fluidic neutronium, and releasing vast amounts of energy in the form of a core collapse supernova explosion. And the supernova in our study, catalogued as SN23E36, had 10 times the explosive energy of a typical supernova. A report in the journal Nature Astronomy suggests that SN23E36 may be an example of what's known as a pulsational pair instability supernova, possibly formed through the merging of two massive stars just prior to the explosion. One of the study's authors, Ido Berger from Harvard University, says this supernova is spectacular in several ways. Not only is it brighter than any other supernova ever seen, but it has several properties and features that make it rare in comparison to other supernova explosions. The supernova was first identified in 2016 using data from the Pan-STARRS Panoramic Survey Telescopes and Rapid Response System. A 4-year follow-up study then tracked its slow evolution and significant energy release. Archival images retrieved during the study revealed a rising light curve dating all the way back to December 2015, allowing the authors to better understand the nature and explosion of the supernova. In a typical supernova, radiation in visible light accounts for just 1% of the total explosion energy of around, say, 10 to the power of 51 ergs. But in SN2016 APS, the explosive energy was 10 to the 52 ergs, which is unprecedented, and the supernova radiated about 50% of this energy, making it outshine normal supernovae by 500 times. The intense energy output pointed to an incredibly massive progenitor star, at least 100 times the mass of the Sun. The authors don't believe the explosion got that big on its own. Spectroscopic observations during the follow-up study revealed a restless history for the progenitor star. In the final years before it exploded, the star shed a massive shell of gas as it pulsated violently. And it was the collision of the explosion debris with this massive shell that led to the incredible brightness of the supernova, essentially adding fuel to the fire. But SN2016 APS also held another surprise for scientists: unusually high levels of hydrogen gas. Now, massive stars typically lose the majority of their hydrogen to stellar winds long before they begin pulsating. The fact that SN2016 APS held onto its hydrogen suggests that it was most likely composed of two less massive stars that had merged together, since lower mass stars can hold onto their hydrogen for longer. The newly merged star would have been heavy with hydrogen, and also high enough in mass to generate powerful gamma rays in the core, which would interact with atomic nuclei to produce electron-positron pairs that annihilate each other, in the process producing more gamma rays and triggering more pair instability. And pulsating pair instability supernovae are caused by draining of the star's energy in the production of these electron-positron pairs. But while pair instability supernovae completely disrupts the star in a massive supernova, the star's pulsational pair instability eruption sheds a quarter of the star's mass first, making it too small for continued electron-positron pair creation. And the authors suggested then underwent a core collapse supernova or hypernova. This is SpaceTime. Still to come, Bepi Columbo swoops past the Earth at 30 kilometres per second. And stunning new images reveal fine threads of million-degree plasma woven through the Sun's atmosphere. All that and more still to come on SpaceTime. The European Space Agency's Bepi Columbo spacecraft has just undertaken a close gravity-assist flyby of the Earth, swooping down over the South Atlantic Ocean at an altitude of just 12,677 kilometres. While most gravity assists are designed to slingshot a spacecraft to a faster speed, this one was designed to slow down the probe from 30.4 kilometres per second down to just 25 kilometres a second, without expending any propellant. Due to the enormous gravitational field of the Sun, getting to its nearest planet Mercury can only be achieved through a series of complicated manoeuvres. And the Earth flyby was only the first of 9 gravity assist manoeuvres awaiting Bepi Columbo during its 7-year journey to Mercury. The spacecraft has now been flung towards Venus, and in October it'll perform the first of 2 flybys of Venus. The final 6 orbital tightening manoeuvres will use the gravity of Bepi Columbo's ultimate destination, Mercury. The Earth flyby has given mission managers a chance to test their science instruments aboard Bepi Columbo, examining the Earth-facing side of the Moon spectroscopically in the thermal infrared for the first time. And without any absorption from Earth's atmosphere, the view from space provides valuable new data for lunar research. Bepi Columbo uses a spectrometer which covers a wavelength range from 7 to 14 micrometers, as well as a radiometer with a wavelength range of 7 to 40 micrometers. It's capable of identifying minerals in the mid-infrared at a spatial resolution of 500 meters from distances up to 740,000 kilometers away. Bepi Columbo was launched back on the 20th of October 2018 aboard an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana. It's the most expensive European project to explore another planet ever undertaken. The only other spacecraft to have visited Mercury were NASA's Mariner 10 mission in the mid-1970s and its more recent Messenger mission, which orbited Mercury from 2011 to 2015. Bepi Columbo will study Mercury's internal structure, its planetary environment, its interaction with the near-solar environment, and the solar wind. The spacecraft consists of 4 sections, which detach at specific points along the mission's journey. The 2 primary sections are the European Space Agency's Mercury Planetary Orbiter and the Japan Aerospace Exploration Agency's Mercury Magnetospheric Orbiter. The two orbiters will orbit Mercury at different altitudes. The Mercury Planetary Orbiter is designed to analyse the planetary surface and composition, while the Mercury Magnetospheric Orbiter will explore its magnetosphere. A third section, the European Space Agency's Mercury Transfer Module, is located at the base of the stack and supplies power to support the two orbiters as well as propulsion during the cruise phase of the mission. It also protects the orbiters from the extreme temperatures as they get closer to Mercury and the Sun. Then there's also a magnetospheric orbiter sun shield and interface structure. It's fitted between the two orbiters and will provide additional protection for the Mercury magnetospheric orbiter before it enters orbit. Surface temperatures on Mercury range between 430 degrees Celsius on the day side to minus 180 degrees Celsius on the night side. On the 5th of December 2025, after 6 flybys of Mercury, Bepi Columbo will enter an initial capture orbit. This report from ESA TV.
Since its launch almost 2 years ago, Bepi Columbo has been steadily making its long journey to Mercury, the innermost planet in our solar system. During this time, instruments have been checked and software updates installed. The trajectory has also been refined by firing its thruster and solar electric propulsion system. This is commanded and checked regularly from the ground. The spacecraft is deliberately travelling via a scenic route. The flybys put on the brakes, reduce its speed and help obtain the correct final orbit around Mercury. During the first flyby, Bepi Columbo will take much closer images of the Earth and Moon, and a selfie or two, as it did shortly after launch, showing one of the unfurled solar arrays and 2 antennas. Within hours of the flyby, scientists will use the opportunity to calibrate the onboard ultraviolet spectrometer, Phoebus. They then have several days to make measurements and checks on some of the other instruments and sensors, with a nail-biting half hour when, due to its position with the Earth, there is no contact with the spacecraft. Regular spacecraft and instrument checks on its 2 orbiters from ESA and Japan will continue after the Earth flyby, with further software updates and fine-tuning. Mission scientists will also operate some of the instruments to monitor the solar wind and examine how the Sun interacts with the spacecraft. Although no science was originally planned during the journey, it was also discovered that the Mercury gamma-ray and neutron spectrometer inside the European orbiter can detect gamma-ray bursts, another added bonus. The main aim of the flyby, however, is to put on the brakes and decelerate the spacecraft into a closer orbit towards Venus, its next pit stop. Bepi Columbo will fly by Venus in October, with a second flyby around the planet in 2021. 6 further flybys will take place around Mercury before the spacecraft arrives in the planned orbit in December 2025, 7 years after launch.
A new study has revealed the Sun's outer layers are filled with previously unseen, incredibly fine magnetic threads, extremely hot million-degree plasma. These new high-resolution observations, reported in the Astrophysical Journal, will provide astronomers with a better understanding of how the Sun's magnetized atmosphere exists and what it's made of. Until now, certain parts of the Sun's atmosphere had appeared dark, mostly empty, but the new images have revealed these 500-kilometre wide strands with hot electrified gases flowing inside them. The exact physical mechanism that's creating these pervasive hot strands remains a mystery. Researchers want to know both how and why they form, and what they tell science about the eruption of solar flares, coronal mass ejections, and the solar storms they produce, which can affect life on Earth. The ultra-sharp images were taken by NASA's HI-C, High-Resolution Coronal Imager Telescope, flown into space aboard a suborbital sounding rocket. The telescope can pick out structures in the Sun's atmosphere as small as 70 kilometres, the highest resolution images ever undertaken of the Sun's atmosphere. Scientists are now developing plans for another high-C launch, and overlapping the mission objectives with those of NASA's Parker Solar Probe and ESA's Solar Orbiter. This is SpaceTime. Still to come, new studies suggest only 6% of COVID-19 cases have been identified, and the Great Barrier Reef experiencing its third coral bleaching event in 5 years. All that and more still to come on SpaceTime. And And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that the current estimate for the spread of the deadly COVID-19 virus are being dramatically underestimated, and the true number of current infections is more likely to be in the tens of millions. The official World Health Organization figures show just over 2 million cases of COVID-19 have been reported so far globally, with the death toll from the disease, which originated in Wuhan, China, now approaching 200,000. However, a report in the Lancet Medical Journal claims that countries have on average only discovered about 6% of their true coronavirus infections. This means the true number of actual COVID-19 cases are being dramatically underestimated. Insufficient and delayed testing may explain why some European countries, such as Italy and Spain, are experiencing much higher casualty numbers relative to reported confirmed cases than, say, Germany, which has detected an estimated 15.6% of infections, compared to only 3.5% in Italy and 1.7% in Spain. Detection rates are even lower in the United States at 1.6% and the United Kingdom at just 1.2%. Now, in sharp contrast to this, South Korea appears to have discovered almost half of all its COVID-19 infections. A new study has confirmed that the risk of dying from COVID-19-associated pneumonia is highest in people over the age of 65, especially those with other major illnesses such as heart problems and diabetes. A report in the European Respiratory Journal found multiple organ failure, especially respiratory failure and heart failure, occurred rapidly after patients were admitted to hospital. They stress that intensive care should be provided as soon as possible for patients with severe COVID-19 pneumonia. Australia's iconic Great Barrier Reef is experiencing its third coral bleaching event in 5 years. Scientists with James Cook University say the 2020 bleaching is severe and more widespread than earlier events. The findings are based on a study of 1,036 reefs during the last 2 weeks of March. Researchers say it's also the first time that severe bleaching has struck all 3 regions of the Great Barrier Reef, the northern, the central, and now large parts of the southern sectors, all at once. Coral bleaching at regional scales is caused by thermal stress due to spikes in sea temperatures during unusually hot summers. And thanks to global warming, we're getting more and more of those. The first recorded mass bleaching event along the Great Barrier Reef occurred back in 1998, then the hottest year on record. And 4 more mass bleaching events have occurred since, as more temperatures were broken by global warming in 2002, 2016, 2017, and now 2020. This year, February had the highest monthly temperatures ever recorded on the Great Barrier Reef since the Bureau of Meteorology sea surface temperature records began way back in 1900. Many corals die when bleaching is severe. In fact, in 2016, more than half of all shallow water corals died in the northern region of the Great Barrier Reef. Marine biologists have discovered a giant 50-metre-long siphonophore, possibly one of the longest animals ever recorded, among 30 new underwater species discovered during an expedition exploring the Indian Ocean's Ningaloo submarine canyons. Scientists from the Western Australian Museum, Curtin University, Geosciences Australia, and the Scripps Institution of Oceanography took part in the month-long expedition aboard the Schmidt Ocean Institute's research vessel Falkor, using an underwater remotely operated vehicle, or ROV, diving to depths of 4,500 metres. The expedition has allowed scientists to collect the first giant hydroids in Australian waters, discover large communities of glass sponges in Cape Range Canyon, and observe for the first time in Western Australian waters the bioluminescent Tanning's octopus squid. They were also able to study long-tailed sea cucumbers and a large number of unique mollusks, barnacles, and squat lobster species. But one of the highlights of the expedition was the sighting of the largest specimen ever seen of a giant siphonophore Apollomena. Siphonophores are massive gelatinous string-like floating colonies of tiny individual zooids that clone themselves thousands of times into specialized bodies that string together to work as a single organism. Well, despite promising on numerous occasions to end the country's horrific wet markets, China has officially approved their reopening as the global COVID-19 coronavirus pandemic continues to wreak havoc around the world. Unsurprisingly, the corruption-stained World Health Organization is backing China's decision, even though China's wet markets have been found to be the viral epicenters for most of the world's recent pandemics, including bird flu, SARS, and COVID-19. These disease-ridden, blood-soaked markets don't engage in any animal welfare practices, with highly stressed animals commonly butchered alive. Beijing has introduced temporary bans on the consumption and farming of wild animals, but admits they won't be policing it. With the details, Tim Mindham from Australian Skeptics.
China has made a judgment fairly recently that they're putting a ban on the consumption and farming of wild animals. Now, it has to be wild, so it's sort of taken from the wild rather than bred necessarily. This has been a major issue, obviously, especially with the coronavirus. This is partially in response to that. But the trouble is that, in certain places, obviously, the eating habits of Chinese people in China is there's a lot of people eating exotic animals. So apart from the danger of actually turning these animals extinct, there is also the danger of sort of bringing in diseases that shouldn't be amongst the human population, and that seems to be what's happening.
As we saw with the bird flu epidemic, doesn't have to be exotic animals. Domestic animals are just as good. Same with swine flu at providing viruses which can kill.
Yeah. But I mean,
the conditions under which they're kept and under which they're killed, that's the issue, surely.
Yeah. Well, that's what it sort of talk about, these wet markets in
horrible,
Wuhan.
horrific places. These are true hellholes.
Yeah, well, especially for the animals, who are kept in tiny cages.
That's what I meant. And sometimes they're cooked alive. I mean, how could any civilization do such a thing?
Well, the interesting thing is just recently, just the last couple of days, the Chinese government has recommended bear bile as a treatment for coronavirus.
And that bile is taken from live bears who are kept in cages barely larger than they are.
That's right. But the thing is that apparently
another disgusting habit.
Yeah, apparently there's a lot of people that prefer wild bear bile. So you have to grab one from the wild and bring it in and then pump it, sort of put a little tube into its bile and drain it that way. So rather than ones that have been bred in captivity. So there's a lot of double standards here, that should really be clamped down on totally. Areas across China as to the attitude towards eating wildlife, what's been happening with the coronavirus in places like Beijing, there's a very strong feeling against eating wildlife, as has been practiced elsewhere. But, other places, obviously, it still goes on.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.